to help my brother Jim if he cannot sleep tonight. Right. Good evening. So, the idea for today is that we want to finish up chapter 2. I think we have been in chapter 2 for a very long time. It's time to move on. Okay. So, I will try to finish up some more architectural pattern and then we are done. Before I start, anybody would like to raise any issue, any problem, any question from last week discussion? Any dissatisfaction, any recommendation? Group 1, 2, 3, and 8. How's your assignment going on now? 0. Alright, good. Other than that, good. No worries. Whatever that you do, you have my full support. You don't do your assignment, you want to do it one day before submission, you have my full support. No worries, because I'm not the one that marking your paper. Other than that, any other things? Anybody don't understand the assignment? Group 1, 3, 1, 2, 3, 8. Right, since no one come to see me from this group, I assume that everything is beautiful, everything is nice. Right, so if you have anything, since I don't have a room, so my space is always open. That can be canteen, that can be anywhere I see, I'm open to welcome you if you want to talk and see me. Right, let's do a quick recap from last week. So this is the two most important takeaway from last week. Number 1, we discussed about architectural view. So basically, architectural view is just a set of information from your design activity that is meant for a certain or specific stakeholder. Remember, when you do your software design, you start from architecture. From architecture, you do component. From component, you do class. Class, you do algorithm, blah, blah, blah. And then you do GUI and everything. So you have a lot of things happening in software design. Compared to SRS, compared to SRE, you only focus on requirement. You only focus on functionality, non-functionality. So basically, the informations are nearly only one information available in SRS, function. So everybody who read your document, they only focus on function. But when it comes to software design, there are many deliverables, there are many outcomes, there are many output that is produced starting from software architecture until you come out with algorithm for all the method in the classes. What happens is that when people read your SDD, different people requires different information. They will not be interested to read the whole SDD from page 1 until page 100 and whatnot. For example, programmers are not interested with GUI. They're only interested with class diagram. They are only interested in component diagram. Right. So in order to create that segmentized input or to create group of information, so that's why we have the 4+1 view. Right. We have view called development, where it focuses on the component that you need to develop. You have view on deployment, the information about how to install the system at the client side, configuration component. Then we have process, step by steps required for you to execute a certain function. And then you have logical view, which is the internal structure of your system, consisting a set of class diagrams. So programmer will be interested with logical and development, or maybe programmer may be interested with process and development. Client may be interested with process. Project manager may be interested with structure. So it based on their role, it based on their position, and then they will search for information related to their position. So that's what we call as 4+1 view. Then we move on to architectural pattern. Before this, we discussed about architectural style, architectural pattern. So I'm not going to repeat what is style, what is pattern. I hope everybody already discussed it in the tutorial. Okay. So last week we stopped up until data center architecture, but just a quick recap. We start with hierarchical layer. In hierarchical layer, we have multiple layer, 3 layer, 4 layer, 5 layer. How many layer you want? Up to you. But the layer have 2 categories. We have open layer, we have closed layer. Open layer means that a layer can talk to another layer, not necessarily under him. meaning that I can skip a few layer and then talks to that particular layer under me, but maybe 2 layers below me. But when we talk about close layered architecture, that particular layer must talk to the layer immediately under him. I cannot skip, right? For example, layer 1 must talk to layer 2. That one is closed layer. Layer 1 can talk to layer 4. That one is open layer. But the communication must always be top down. Okay, must be always top down. Right. Then we have data-centered architecture. Data-centered architecture only says this: I have a big, humongous data. How can I make the data transaction become faster? That is the main aim of data-centered. So there are two different architecture under data-centered. If the system is AI-based, we call the architecture as blackboard. But if it is a normal-based system, then we call it as repository architecture. But the structure is the same, right? The structure is the same. I have the data at the center, and then all my software component around the data, and then they can talk directly with the data. But between the software component, they are not allowed to communicate with each other. When we don't allow communication between components, what happens that we cut off some unnecessary transaction time. Right, so that's how we speed up the data transaction time in data-centered architecture. So for today, we are going to go into, oops, wrong slide. Sorry. Alright, so for today, we are going to go to the third category of classification. So today we are going to go to data flow, and distributed and interactive. Okay, so let's look at data flow. Okay, data flow is an architecture created for a system that really focus on flow of event. Okay, that is called data flow architecture. So if I have a system and that system is a flow of event, means that the system always follow a certain step. After step 1, the system must go to step 2. After step 2 complete, then only I can go to step 3. So it is a flow of event. If your system behave like that, means that it must do 1, 2, 3, 4, 5, then only the process complete. So if the nature of the system is like that, then the architecture suitable for your system is called data flow architecture. Okay, data flow classification architecture. So under data flow, there is one architecture that is popular called pipe and filter. Right, we call it as pipe and filter. So category, no, I don't understand why the whiteboard must be at the back. Can the whiteboard go to the front? That's right. Okay, let's experiment this. Oh, you have insurance? You have insurance? If you have insurance? Okay, nice. Right, category data flow. Right. What kind of system? System that only that focus on sequential event. Okay, sequential event. Give me one system that focus on sequential event. That system must complete from step 1, step 2, step 3, step 4, step 5, done. ATM. No, ATM can go anywhere, right? I enter my card, I enter my PIN number, but then I can go anywhere, right? I can go to deposit, then patah balik. Not enough money. I go to somewhere else. Same goes, e-commerce, Shopee or whatnot. You can put things into cart and then you just leave it, right? Then you can come back, then you pay. That's it, done. But this one need to be done continuously. You cannot just simply stop. Food ordering, same thing. You food order, then you cancel, and the brush totally different, right? this is a system that must be done continuously, and you cannot, most of the time you cannot stop lah. You cannot stop. Then traffic what? Traffic regulation, same thing. First I can turn on traffic light at this place, and then I can go to other place and whatnot. So there is no specific sequence that I need to follow, right? But this one I need to do a specific sequence. Right. I give you one simple example. Salary processing system. Right, salary processing system. Let's say in UMT, salary for all university staff will be processed exactly on the 20th, on the last day of every month. So what happens that on the last day of every month, automatically the system will take all the information, all the staff information, and then start calculate the salary. First, what we do, we identify the position, then we identify the base salary, then we identify what are the allowances for this particular staff. Then we identify what are the amounts that need to be cut off from the amount, from the base salary plus allowance. Let's say your tax, EPF lah, whatnot, blah blah blah. So once calculation has been done, then we need to print out the pay slip. Once pay slip is done, then only the money will be sent out to the bank. See, it's a sequential process, and then it cannot stop. It's 5 o'clock. The system stop. Stop at what? Stop at print salary, but the money still not transferred to the bank. So what happened on the first of every month? People will get crazy, right? Where's my salary? Yeah, of course, system it is automated lah. Alright? Just that the human intervention is that I need to set up the parameter when I first run the system. Okay? So, for example, another example is what? Another example, end of year billing, end of year income, end of year reporting. Okay? So, this kind of system that have a certain sequence usually are meant to be executed at a certain period of time. It doesn't active all year long. It doesn't active 24 hours 7. It only activated when that particular period of time comes in. End of year, end of month, that kind of thing. Alright? Graduation. So when you graduate, we need to process 1,000 data of student. We need to check, are you really qualified to graduate? So, what is your CGPA? Have you taken all subjects? Do you have any hutang? Blah, 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 blah. So the process will be done in sequential method. Correct? So that kind of process is what we call as sequential system. So that kind of process, you can use data flow. So in data flow, we have one architecture called pipe and filter. Right? In data flow, one architecture that is under this category is called pipe and filter. Right, so what is pipe and filter? So what happens is that pipe is this. This is pipe where you have your data. Okay. For example, let's say first I want to get orang yang berhutang. That one is called debtor. Debtor, is it? Pemberi hutang is what? The one that borrow? Borrower. The one who give the money? Debtor. Borrower. Along. Kawan, the person who borrow money, debtor or borrower or what? What's the name?
Borrower.
Debtor. Debtor. Chris.
Borrower.
Done. Yeah. Nobody understand this? I don't care. Okay. So let's say we start off with 10,000 penghutang. 10,000 data, 10,000 data of penghutang. Let's say I am ahlong berlicense. So I ask my system, I'm a modern ahlong. Okay, generate report. So the data will take 10,000 penghutang. Okay, now what happens that? First we will do, okay, this is called pipe. Okay, this is called pipe. Then the process. So this is the process. So this process is called filter. Right? That process is called filter. Right. So maybe for example, I want you to search how many already die. Right, from 10,000 I need to know how many of them already died. Since I'm a good ahlong, I will not disturb the family. Right, then the data change. Now, I have penghutang, but now I have penghutang yang, I don't like this word lah, but it's okay lah. Penghutang yang hidup. Right, a bad ahlong, cincai semua, mati pun the family need to pay. Right, okay, now I'm a good one. So this is called filter. This is called pipe. Every time a data go through a filter, the data must change. Remember, for salary, I started off with allowance, basic salary plus allowance. When I go to filter, let's say minus tax, then the data now change, meaning that amount without tax or amount after tax. So the name must change. Right, now, then I go to another filter. Okay, now I want to say filter number 2. Who has paid this month? Okay, who has paid this month? So now this is filter number 2. Okay, so from filter number 2, what happens is that now I can have concurrency. Okay, this is the beauty about pipe and filter. I can have concurrency. Concurrency means that I can have two functions run at the same time. Two function running at the same time. So now from who has paid this month, so now I have yes, I have no. For example. So now I have one filter. For those who say yes, I'm going to send them flower. Send flower for thank you. Okay. Then the process terminate. But for those who says no, we say, okay, send red pin. Right, send red pin. Okay, then done. So this is called pipe and filter. Right, this is called pipe and filter. So the system must be done in sequence, and then it cannot stop. Usually it will go one shot. For example, like salary processing, report processing, graduation processing, all these things must be done at the end of the month, at the end of the year, at the end of the study. So usually it happens at a very specific time. So that is called pipe and filter. But be careful, if your flow doesn't have concurrency, means that if your flow doesn't have a breakdown like this, means that it's just one linear line. Okay, it's just a one linear line. For example, like, okay, filter number 1, filter number 2, filter number 3. So these are filter. Oh yeah, by the way, to avoid confusion with layered architecture, it is advisable for you to draw filter in horizontal format. So this is pipe, this is filter number 1, pipe, this is filter number 2, pipe, this is filter number 3, right? Pipe, then this is filter number 4, and then the process end. Okay, if you do like this is not pipe and filter. It has a much more specific name. If your process flow doesn't have concurrency, doesn't have more than one function that run at the same time, then we call this as batch sequential. Okay, we call it as batch sequential. So under data flow, we have pipe and filter, batch sequential. Okay, pipe and filter is a more specific architecture for a system that have concurrency. For those who don't understand what is concurrency, a system that have more than one function that can run at the same time. How many of you have learned parallel programming, multi-threading programming, concurrency programming? Those are actually similar things, different name. In Java, no one learn about multi-threading in Java. Multiple methods run at the same time. Nothing much I can do about that. Right, so this is called data flow architecture. So if your system is sequential, okay, your system is sequential in process. Oh yeah, I forgot another characteristic. The data usually must be in bulk, or we call it as in batch. We don't process 1 or 2 data. No. We process 1,000 data. We process 10,000 data one shot. We call it as in a batch, right? For example, when we process salary for all TAR staff, we are talking about 5,000, 6,000 staff one shot. Right? When we talk about processing verification for graduation, we are talking about, let's say, 10,000 data one shot. So the data must be processed in bulk, big number, not one data at a time. We don't do that. Okay. Right. Question about data flow. I'm not using the slide because the slide is quite lengthy. I think the slide is for you to read. I give you the summary of it. Okay, the quality property that pipe and filter support. So if you use pipe and filter, you are given a guarantee that your system will be able to achieve extensibility, efficiency, reusability, modifiability, security, and maintainability. Right. I want to focus on one thing. How does this is modifiability? Can somebody explain to me how does this architecture support or achieve modifiability? I can just simply add the branches, right? So yeah, that's true. So modifiability in that pipe and filter is achieved by having independent filters. So each filter are independent. So if you remove them, if you change them, if you modify them, or if you add more filter, it will not disturb all the existing filter. So that's how pipe and filter achieve modifiability. Boleh? Right, the advantages of pipe and filter. It can modify or the filter can be modified or replaced easily. So that support modifiability. The filter can be rearranged with little effort. That one is maintainability. The filters are highly reusability. Highly reusable because they are independent. As long as the data that come into the filter must follow a certain format, then this filter can be used in other system. Alright, let's say this one is system for pemberi hutang berlesen. I can give this to the bank. Right, maybe there's a new bank, right? Grab Bank is opening, is going to start their own digital bank. I can offer them, hey, you want my pipe and filter? I can sell you my filter. I can sell you my code for filter because it is independent. Right, so that is called pipe and filter. The disadvantage, let's look what's wrong. Why you should not use pipe and filter. Filter communicate only through pipe, making it difficult for them to coordinate their activity. Meaning that each filter only able to know the data that coming into them. So if you ask this filter to communicate with another filter so that we can make the data become more solid or whatnot, it cannot happen. It cannot happen. Okay, it cannot happen. Imagine this lah. Imagine a car assembly line. You go to Proton factory, you see a car being assembled starting from the frame. Then I put the engine. Then I put the wheels. Then I put the hood, and then painting. So the process, basically the process cannot be disturbed. No, the sequential must be done. Meaning that the sequential are quite rigid. Right? Even though you can change the filter, you can arrange the filter, but the outcome will be different. Okay? The outcome will be different. Filter usually consume and produce a very simple data stream, for example, character and whatnot. So most of the time, they only process string, they only process number, they only process what we call it, basic data type. What's basic data type? No. Basic is not the right word. What's the technical term? Primitive data type. Thank you, Sam. Right, primitive data type. So if the processing process primitive data type and then it must be done in sequential, then please consider this. But if the data that you are processing are not primitive, for example, knowledge, right, in AI, then pipe and filter is not the best architecture. Error handling can be very difficult because error information can only be output for or passed along a pipe. The difficulty of error detection and recovery make this style inappropriate when reliability and safety are important. Meaning that, let's say something wrong here. Right, the definition of my penghutang die, somehow my programmer writes something wrong or whatnot. What happens that the error will be carried forward. And then there is a possibility that even this filter doesn't know that this data now has error. That's problem. So when the final outcome is produced, and then when a human intervene, when I look at the data, how come my data is different? Last month, 5,000 people died, so I should have 9,500. Then how come this year now I have 9,900? Only 3 new penghutang in my list. See, the data is no longer tally. So what happens that you need to check each filter individually. Where is the origin of the error? Right? Because they are independent filter. You cannot get the notification where the error come from. Especially when the error is very subtle. Logical error, for example. Right? Logical or semantic error. Something that cannot be detected by your editor. Semantic error. So you need to check every single filter one by one. So error checking will be a disaster. Right, okay, by the way, the last one, okay, this is interesting, but we will discuss this more in detail in chapter 5 or chapter 4. Even though pipe and filter promote concurrency, in other words, it also promotes speed. When you can do concurrency, meaning that your system speed can go a little bit more faster. But however, the correctness of data, when it comes to concurrency, is not guaranteed. Okay, what do I mean by that? We will discuss this in tutorial lah, but because this is not part of the discussion. Okay, let's say I have function 1, I have function 2. Right, let's say I have system.out.println 2, system.out.println 3. Okay, let's say this is a method, okay? Let's say this is a method called S1. This is a method called S2. Okay. Right. In a normal programming, we will call the method in sequence, right? For example, we say S1, S2, S2, S1. So what is the expected output? It will be 2, 3, 3, 2. Right. But in parallel programming, let's say I send S1 and S2 together. So both will go to the CPU together. Okay. Using parallel programming, I call the method together. S1, S2 call one shot. Then they will go to the CPU to be processed. Right? As a programmer, I cannot say 100% guarantee I will get 2, 3. No. The result can also be 3, 2. Why? It depends on which function that goes into the CPU first. And who determined that? The CPU. Right? Even though in parallel programming, there are a few control, there are a few coding that we can do to force the CPU to accept the function in a certain sequence. But at the end of the day, CPU will give you the final ultimatum. You follow me. Right? You follow me. So, it cannot give you a guarantee the answer will be 2, 3. Sometimes when you display, you might get 3, 2, or sometimes totally weird number. Alright, so that's why when it comes to concurrency, that's why we put a disclaimer here. Gain from concurrency may be illusory, meaning that the final outcome when you have concurrency module in your system can be undetermined, cannot be determined. There's no 100% guarantee the output will appear exactly like how you want it to be. Right? Because what happens that your code will be override by the CPU. Because CPU also have their own concurrency module developed, controlled by the OS. So you cannot override that. Okay? So that's why for a system that requires reliability, 100% correctness, then pipe and filter is not the best architecture. Right, this is an example of pipe and filter. So if you have concurrency like this, sorry I don't bring my pointer today. If you have concurrency like this, okay, if you have concurrency like this is called pipe and filter. But if your architecture is a linear process like this, then we call them as sequential, batch sequential. Right, done. Question. Any question? No? Good. Any confusion? Right, now we go to the fourth category, distributed system. Okay, now we come to distributed system. Okay, for this, okay, let's simplify the definition of distributed system. Distributed system, if you want to make it simplified for everybody to understand, is that I must have a server. Okay, I must have a server or I must have a host. So automatically my system will become distributed system. But there are many form, there are many format, there are many style of distributed system. But we're not going to discuss it. The one thing that I want you to remember is that if your system is located inside a server, and this is your app, right? And then you have client. So everybody who want to do transaction, it must go to the server. Basically your web application lah. Okay, your web application. This is considered as distributed system. This is the browser, right? This is the browser. Okay, this is called distributed system. Okay, I give you another example where we don't need to use web application. Let's say file printing system. Okay, for example, let's say these are the desktop of every lecturer in TAR UMT. Right, these are the desktop of every lecturer in TAR UMT. Right, let's say this is at level block A, level 2. This is at block D, level 1. Let's say this is at Tun Tan Siew Sin, TTSS, level 5. Right, so I want to print. Okay, I want to print my document. So what happens that when I press Ctrl P, print, that document will not be sent directly to printer. What happens that, let's say I am from block A, I press Ctrl P, CTRL plus P. So what happens that the data, the document that I want to print will go into a server. Right, will go into a server. So this is, here I have a printing management system. Right, so what happens that the file will go into a folder with my name. Let's say Rizwan. How does the machine identify my name? From the PC, network, or sometimes we need to log in first before you can press Ctrl P. Depends on what kind of system that you use. So now what happens that, let's say after that I go to block D, and then these are all printer. Okay, printer number 1. Let's say this is printer number 2. Let's say this is printer number 3. This is at block P, block Q, block M. Alright, let's say I'm going to give lecture in block Q. Right, but I do not want to bring the paper with me. So what I do is that I press Ctrl P for my room at block A. It goes to the server. The data, the document will be sent, will be kept inside the folder. Then when I go to block Q, I enter my ID, I enter my password. Then the system will go back to the server, search for my name, and then send all the document to this printer. So now my document will be here. So all I need to do, I just select what document that I want, and then it will be print out at block Q. This is also client server. This is also considered as distributed system. Why distributed system? Because my application is hosted inside a server. Okay, question on distributed system. Okay, nice. Now, if you have this kind of system, these are the architecture that we suggest for you to use. Let's look at number 1, client server. Okay, the first architecture under the category of distributed system, we have client server. So it means that this one lah, I have client. This is my client. All the PC all over the world using browser. And this is where my application is hosted. Same goes here. This is also server client. This machine here is client. This printer here is client. This is my server. So this is also client server architecture. Alright. So you can use client server. So what happens that in client server there is one term called tier. To my team, sorry, not to my team, to tutorial 4, 5, 6, 7. I mentioned tier is a server, right? Sorry, my fault. Tier is a machine. That machine can be categorized either a client machine, means that a machine that requests for the service, or a machine that hosts the application, that provide the service, which is the server. So that is called tier. Right? That is called tier. Okay, for example, like this one. Let's say these are all the user all over the world. But this is considered as one client. We don't consider this as 1 million client. No. Client means one client. Right? How many client we have, don't care lah. Client. So this is client. This is server. So this is called two-tier architecture. Right? That one is called two-tier architecture. How about this one? How many tier? Why 2? I have client. This is client. This is client. Doesn't matter lah what type of client, but still a client. Then I have one server. 2 tier. Okay. Now let's try. This is the one that I showed in tutorial. Right? Scalability. Right? You want to make sure that your system is able to perform at a certain normal condition, even though the number of transactions suddenly spike up. Okay, let's say from 8 a.m. until 11 a.m., 11 a.m. until 2 p.m., and then this is until 5 p.m. So the number of user is normal between 8 to 11. Then suddenly 11 to 12, 11 to 2, the number increase and then it becomes normal again. So what happens that during the spike, we want the system to still be able to provide the service at a normal condition. Means that no delay, no lagging. If you promise the client 2 seconds for every transaction, you can still achieve 2 seconds for every transaction, even though the number of transactions increase. How do we do that? So one of the possible way is by having a redundant server. So I have one server here, server 1, then I have a second server, server 2. Right, so this is my application. Okay, sorry, this is my application. So what happens is that I copy the same structure here, right? So when the transaction come, if it is normal, then I will pass it to the main server, right? But during peak hour, I will send some of the transaction to the redundant server. So this is called redundant server, right? Then when I reach normal period, then this connection will be closed off, and then I will synchronize back the data. I will sync back the data. Means that I will copy the data from here and then merge it with data here, because we just want to keep one copy of the data. How many tier? How many tier? Why 3 architect? Why 3 tier? Because I have client. So client is 1. This server is active. This server is active. So I have 2 server who are currently active to serve my client. So I have 3 tier architecture. Right. Using the same diagram, but now different scenario. Now we focus on availability. I want the system to be able. I want the system to always provide service, even in the condition of error. I want the system to provide service even though there is, even though I am in the in error mode, or I have some kind of major error that led to the system got disturbed. Okay, now what happens is that the same architecture, the same drawing. So all my transaction now will come here. Right, everything is good. Right? Then what happens is that suddenly there is a major error. But since I promised my user the system must always be 24/7 available, what happens is that now I divert the transaction to the second server. The previous scenario I call redundant server, but this scenario I call this as mirror server. Right. So this server will be activated while waiting for the main server to be corrected, or to be corrected lah. But once the server is corrected, is up, then I will pass back the process to the main server, and this will become idle. How many tier? For this scenario, how many tier? Right? Why 2? Because I have my client and I have my main server. This is idle domain, not functioning. This only function when this has error. So when I divert the transaction to the mirror server, the main server does not work. It is not part of the architecture, not part of the structure anymore. So it becomes 2-tier architecture. Right, so those are called tier architecture. I'm not going to discuss much what is tier and what not, because we will discuss this again in tutorial. But any question about client server architecture under distributed category? Alright, cool. Now, let's look a little bit more deeper about client. Okay, there are 2 types of client. One is called fact client, and another one is called thin client. Nothing to do with physical structure. These are just logical definition. So, what is a fact thin client? Thin client means that a client that only give and receive input and output. There is no processing in thin client. For example, this is a thin client. This is a thin client. My printer is a thin client. My desktop also is a thin client. For this particular system, both of them are thin client. Why? They don't do any processing. They just provide input and then they display output. When I want to print, I just enter my ID, Control P, and send the document to the printer. Done. I don't do any processing. The printer only receive my ID, send the ID to the server search for my name, the server get my document and then send it back to the printer. Then it will display all the document that I have inside the server, then I print. It doesn't do anything else. So this kind of client is called thin client. Right, thin client. Or if you refer back to my early years, 1990s when the .com era, when people started to develop website like crazy, because that was the trend. We have Netscape Navigator, we have IE. So at that years, during that time, those web browser can only display output and receive input. There's no JavaScript, it cannot do front-end processing, it cannot do AJAX and whatnot. No processing, just input-output. So browser in 1990s are called thin client. It cannot do any processing. So what is a thick client? Thick client is a client that will do some kind of processing. That one is called fat client or thick client. Okay, a client that can do processing. For example, in the modern web application, you can verify whether the input follow a certain format or not. Let's say your password must be 12 character consisting of special character, number, uppercase and lowercase. What you do is that you don't need to do the verification, meaning that you don't need to send the data to the server do the verification and then go back to the client and tell, oh, your password is wrong, not following format. In modern application, that simple verification can be done at the front end. No need to go to server. We can use JavaScript, right? We can use JavaScript, we can use JS to do the verification. Right, and then have you come across when you fill up a form but you forget to fill up one area or one field, and then it give you a red button, right? This field is required. That is not done by the server. That is done by the front end itself, by the browser itself. So any browser that can do any form of processing, any form of transaction is called a fat client, right? But both of them, thin or fat, they have their own disadvantage. Okay, that one we will cover in tutorial, especially when it comes to security. When it comes to security, both thin and fat client have a disadvantages on that particular topic. Right? Questions about thin and fat client? Alright, what is the good thing about client server? Of course lah, you can allow people to access your system from anywhere in the world, right? It is easy to implement without any extra cost and whatnot, and it is easy for you to add server in order to expand the capability or as a backup or as a security features. Oh yeah, I asked again lah. I already asked this in tutorial, but let me ask again. Okay, this is server number 1. I call this as app server. Inside the app server, I have 2 layers. So this is the presentation layer, this is the business logic layer. So now I am combining the layer architecture with the tier architecture. Right? We can do that. So now here to here, here to here. In order to increase the security feature of my system, what I want to do is that now I'm going to put the data layer inside another server. So this is a very common architecture that most web application developer like to do. Okay? So this is called, for server number 2, I call this as DB server. How many tier? Sorry. What is the name of this architecture? Client server, I'm asking how many tier. Client server is this. How many tier? It has a new name now. This is not tier because now I have combined tier architecture plus layered architecture. So what's the name of this architecture? Logically, you can derive the answer easily. 3 tier. Why 3 tier? Now because I have 2 server, 1 client. Remember, a tier refer to a machine. So 3 tier, 3 machine. Client, 1 server, second server. How many layer? 3 layer. The layer is still the same, just that now I separate them. Remember, architecture is logical structure. When it comes to physical implementation, I can implement it in any way as long as you follow the rule of the architecture. So this is first layer, second layer, third layer. Just that physically, now the third layer is inside another machine, but the communication is still top down. Means that presentation must go to business, business only can go to data, it cannot go backward. Right? So this is called 3 tier, 3 layer architecture, usually used for security purposes. Right? So for client server, in general, it can cover interoperability. Okay, I want to talk about interoperability. Interoperability, portability, and compatibility. So these are actually traditional software quality attribute where when we want to develop something in the past when I develop, let's say, a Windows application, okay, and that Windows application need to talk to another application written in Unix or Linux. So what happens that my architecture must include one extra component that will do the translation from Linux to Windows, Windows to Linux. That's what we call as interoperability. But nowadays in modern system, we don't need that. We already have virtual server. We already have virtual box, right? So that issue of compatibility is already covered by OS or by third-party system. So you don't have to worry about interoperability or whatnot. Okay, client server also promote modifiability, availability, and reusability. So this is another client server architecture that does not relate to. Okay, this is relate to web-based application. So you can see here, this internet. So these are my client. Basically, these are browser or mobile app or web app, and then these are all the component. Okay, so we call them as tier or okay, n tier. N tier means that how many machine do you need to create in order to create the structure. Right, so basically we have covered 3 tier architecture, so on. So n tier means that if you choose to use more than one server, 2 server, 2 tier, 3 server, 3 tier. So the aim is that you want to maintain maintainability, scalability, flexibility, availability. Okay, if that is the aim, then you might want to consider multi-tier architecture, right? Multi-tier architecture. Right, disadvantage of n tier. What's wrong if I use more than one server? Your whole architecture can be bloated. Bloated means that you assume that one server cannot support your transaction. Actually, your server is already high-end, it can support the transaction. But since you are worried too much, you introduce a second server. So what happens that your whole structure become bloated. Bloated means that you have unnecessary structure in your system. We call it as bloated. Same goes like iPhone lah. Every time not iPhone, Windows. Every time you update, right? If you look at C partition, the space getting smaller and smaller. Why? Because they install unnecessary patching into our system. Right. Number 2, inflexibility. Although in most cases the use of n-tier architecture increase flexibility, but there are certain scenario if you use more than one server, alright, you will create unnecessary inflexibility. It becomes dependent. Means that the server become too dependent on each other, So if you want to do changes, it will not be possible. Because the communication between the server or between the machine is so tight that it becomes rigid. Okay, it becomes rigid. Okay, before we proceed, any question? As you might aware, I don't give you any rest. Why? Because I promise you, we are going to finish this chapter tonight. By hook or by crook. I'm going to be re-energized at 7:30, so I'm looking forward in the next 10 minutes. We might finish around 8:15. I don't mind. You mind? I don't mind. Okay. Right. 5-minute break. Then we continue.
是，然后他背写的就好像我到底上了，我的手容易打针。为什么？他就是可以吃一口人肉了。我 ASMR。
回家。
我觉得是不是手不要？
不下，
你要背你的洗，
我要不下。
要背的。
你洗一下脸，
洗一下脸。
要不要走走？走走。比较洗脸。
我要先出我的眼珠啊。
不是，你要先出我，不是。
你看下你指甲。
啊？
看你指甲。
看不到了，那个小。
绑的没有？
有吗？
Any questions? Anything that you want to raise? Anything you want to share? All of you are getting red colored because of the heat, right?
Yeah, because one only.
One only. There. One. Okay. Anything related to ocean? Oceanography? Narcotic, not narcotic. I want something start with N. No, anything related to sea, wave. Narcotic.
好像要压死我。
Dory.
Dory.
Safe play is guaranteed. Huh? No, just keep one.
这么？你要想吃啊？
你可以早就知道了，他不是有拉长路吗？
哦，地方。
老粉盒子，有人到中就有啊，你知道吗？
老梗儿子真是，我一个老师是遇到的，然后他是教华的，
也很想用到中就有一个老师。真的真的。哇！
教华其实他是那是那个不差
他一直想要 kiss 你。
嘴巴没啥。
还要等你 kiss 他吗？那只能这样走。我肯定老师。
Alright, now we can continue for another 1 hour. Let's go. Okay. For those who fasting, enjoy your breakfast. For those who are not fasting, enjoy your dinner. Alright, let's continue. Okay, this is also under the category of distributed system. Remember, as long as my system has a server, we consider as a distributed system. But now the nature is a little bit different. Okay, now I give you a scenario. Hopefully this can make you understand the scenario. The nature of the system. Okay, now. Okay, let's say in Malaysia after 2014 tsunami system. 20 where was I? 2005, right? 2004, sorry. 2004, 2005 tsunami. I'm not sure whether you were born yet or not. Okay, so Malaysia was hit by a tsunami, right? Because of the earthquake, underwater earthquake that originate from somewhere. So Southeast Asia, Malaysia was hit. Thailand is the worst, got hit. Philippines also. Indonesia, Aceh, that's the total 100% disaster. So what happened after that? Our government installed what they call as buoy. Right, it's a sensor located along the shore of our coastline, a few kilometers from our coastline. What happens is that if the height of the wave change dramatically, then the buoy will send an alarm to the nautical department or meteorology department. I don't know lah. Jabatan laut lah, Jabatan Laut Negara or Jabatan Meteorologi Negara. What happened? So what happens that those people who live at the shore, like Kelantan, Terengganu, Kuantan and whatnot, they subscribe to an alarm system provided by our government. So the moment the buoy send an alarm system to the meteorology department, and then that information is verified. Okay, so first step, there must be some kind of information sent, right? And then there must be some kind of verification. And then what happens there, I'm going to send alarm to all subscriber. I'm going to send SMS, alert, tsunami coming, or a potential tsunami is coming, take cover. Right, so what happens there, I need to send million of data or million of messages at the same time. So this kind of system is called broker. Broker architecture. So what is a broker architecture? Means that I'm going to have component that request for component that will send data. Alright, and then I will have another component. Okay, this component is what we call as broker. Right, so this guy will verify the data, and then he will take action. Right, and then under broker I have a lot of subscriber. Right, then I need to do some kind of processing. For example, send SMS, send an alarm or whatnot. That one is considered as a broker system. Okay, another example. Let's say there is a fire in this building. So the sensor will trigger the security department. Right, and then at the same time, if the sensor also, let's say we do much more integrated, we send the signal directly to the fire brigade, the balai bomber. Then the balai bomber will come. Right, at the same time, all students through the intranet, you will receive a notification. Alert, DK4 is burning. For example, which I don't think we have that. You die lah. Then we can have another batch of students coming in. Alright. That one is also considered as broker system. The idea is this. If my component has three part. The first part is to receive signal or to process an event. Okay. First part, process event. There's a fire, there's a request or whatnot. Second part, this guy in the middle, the person who verify the event. Is it true there is a fire? Does the signal really valid or whatnot? Okay, after that he will take action. Usually the action will be in the form of spreading news. Distribution. This is the word. Distribute. Right, so I have first layer or first component, second component, and then the last one will be distribution. Distribution means that I'm going to distribute information or distribute something to a very big number of components. By the way, don't limit your imagination only to SMS or whatnot. Sometimes I can also send signal to internal component. Okay, let's say I have one kilang, chemical plant. Okay, let's say I have one chemical plant. Okay, let's say I have one tank that have hydrogen. Right, whatever lah, hydrogen or whatnot. And then there is a heater. So I'm going to burn the hydrogen until a certain temperature. Then on top of the tank, I have a thermometer. Right. Then from the hydrogen, from the hydrogen tank, it is connected to another tank. So what happens that every single tank, they will have a sensor that will detect if there is any malfunction. When there is a malfunction, then it will inform the control room. Right, so when I look, something wrong, malfunction. So I look whether the malfunction is critical or not. If it is critical, maybe I'm going to say shut down all system. So shut down all system is this guy, the broker. So when I press shut down all system, the broker will send signal, off signal to all device inside the factory to shut down. That one is also considered as broker architecture. Right, so there must be some kind of detection, there must be some kind of sensor that send an information to the second guy. The second guy will do verification and whatnot. After that, he will send a lot of signal. Right? So that's called a broker. Okay? Broker. For example, let's say lah, your friend, maybe one of the boys just got dumped. Signal, dump. Right? The girlfriend goes somewhere else. So you as a good friend, what you do? You broadcast information.
Yes.
Right. Christopher is available. Send. Tap. Intranet. Done. Right. So your friend is the broker. You are the signal. The person who receive it is the third party. That one is also considered as broker architecture. Right. So still we need a client server. We still have client server. But the way it produce, the way it respond to the signal, respond to the alarm is different to the normal client server. Okay, a normal client server is like this. I want a service. I want login. Then server will process login and then tells me, okay, login successful, come in. But for broker, different. You tell me, or something happening, so I need to respond. Right? Then I need to inform all my subscriber. Oh yeah, there's another term for this. We call it as publish and subscribe architecture. Another name for this guy is publish and subscribe architecture. So these are all subscriber and this is the publisher. I will publish information. Once I receive something, I will share it with you. Okay, another application. Let's say you are an investor, gold investor. Right? So you subscribe to an application that will inform you the moment the price of gold goes up or goes down. So you are the subscriber. When you install the application, you are the subscriber. Right? Then the system will monitor the price of gold. Maybe they monitor from London Bullion Marketplace, LBMA. So every time the price changes, then the system will send you a notification. So the main component of the system is the publisher that will inform you changes in the price market for gold. Then you are the subscriber. So we call that publish and subscribe. But nowadays people call them as broker architecture. Same thing. Right? Same thing. So what does broker promote? It promotes interoperability, modifiability, portability, and reusability. As I mentioned, interoperability and portability are not really a main concern. Okay, not really a main concern because that now is handled at OS level. So not a worries for you. Right. Next is peer-to-peer. Peer-to-peer architecture is quite straightforward. I have two or more than two machines connected directly to each other. That one is called peer-to-peer. No server. This time there is no server. However, the machine that is connected to each other behave like a client and server at the same time. Okay, this is called peer-to-peer, P2P. Okay, I give you one simple example. This is what I did when I did my degree. Okay, this is my desktop, right? And then this is my friend desktop. And my friend desktop has a printer. Right, in 1999 and whatnot, at that time modem, a simple stupid modem. I'm mad, I'm really mad. Why? Because I need to wait until I'm at year 4 before I can buy my first thumb drive 120 megabyte. It cost me 150 ringgit. One thumb drive. From year 1 until year 3, what do I bring? My 4.5 inches floppy disk. You know the square shape thingy that only have 3.28 megabyte per piece. I still remember my final project, my final assignment for C programming requires me 20 disks. You need to zip. After you zip, you need to cut the file into 20 pieces. Then you need to copy into one disk one by one. Right? Then you go to the lab the next day. You need to combine back all the files. So you need to copy first one by one. Then by the time you reach floppy disk number 9, Error. Two option. You go back, copy, or you just surrender to your supervisor. So usually what we do, 20 times 2. We have 20 the main copy, 20 backup. So we have 4 boxes in our bags every single day. Right. So I need to wait until year 4. I'm relying on PTPTN. So 240 megabyte thumb drive, 150 ringgit. You guys are damn lucky, you know, right? So okay, now at that time modem is super expensive. We cannot buy modem, we cannot buy hub. So what we do, we do direct network. We buy the network cable, but we change the configuration of the color. That's it, the configuration of the cable. If you you call it as RJ45, right? The network port is RJ45. If you take the network cable, it has a certain arrangement of color, right? What you do is that you change the position of the color, then you can connect from machine to machine directly. What do we call this cable? I cannot remember the name of the cable. The same cable, but once you arrange the color differently, then you get a different function. Then I cross cable. Thank you. Then I can connect from one machine to another machine. Okay, now this is called peer-to-peer. This is called peer-to-peer network. So when I connect, I just go to network and share it. This guy will give me the ID and password, and then what happens there, I can access his printer using his desktop. Alright, so basically I have 100% control on his machine at the same time. He use his machine, I can use his machine too. I can delete his OS. No. Bye-bye. Right. So, anybody use torrent? Torrent to download movie and whatnot. So, torrent is a peer-to-peer network. So, that's why we don't encourage you to use torrent. So what happens that anybody who subscribe to torrent, basically you are allowing direct access from the torrent server into your machine. So let's say I'm searching for a movie. Okay, let's say like this, eh? Okay, let's say these are all the subscriber or person who install torrent. Right? Install torrent. Okay, let's say this is the torrent server. So what happens that all of you basically give permission to this server to have direct access to your machine. Direct access. Let's say I'm searching for a movie called Dune. Right, Dune 2 can copy. Dune 2 can copy. So what happens that the server will search for every machine that have Dune directly in your hard disk. And then they will become the seed. So each machine will contribute a small piece of the movie. And then it will go into your machine. So that's how torrent works. So what happens that some people, they got naughty. Instead of putting movie, they put virus. .mpg. Right, movie most of the time is MPG or AVI or something, right? So I can create some, I can just take my Dune movie, I infected with virus, and then I put it under the folder for torrent. So anybody who download my file, congratulations. You got my virus. So use torrent carefully. Make sure you have a very strong antivirus to protect your machine, because you are opening that segment. So this is called peer-to-peer architecture. Right? Peer-to-peer architecture. The problem with peer-to-peer architecture is that you are allowing direct control of your machine. Okay, in terms of architecture, peer-to-peer means that you are providing direct access to all components without any particular rule. Data layer can be accessed by business logic. Presentation layer can be accessed by business logic without any particular rule. It becomes peer-to-peer network. So be careful if you want to use this architecture. Right, so this is called peer-to-peer architecture. Right, question. Any question? Okay. Okay, the last architecture under the distributed system. We still have 15 minutes, don't worry. Okay, the last one is called service-oriented architecture. Okay, now what is service? Let's understand this first. Many think in the assignment say, oh, we want to use SOA, service-oriented architecture, or we want to use microservice architecture. What is a service? Let's understand that first. What is a service? Payment gateway, service or component? Payment gateway, service or component? Service. Google Map. Google Map that you use inside your mobile app, service or component? So what is service? Understand this, then only we can proceed to the discussion about SOA. Remember, we have software component, then we have software service. What's the difference between service and component? Then from service we have microservice. So our friends here says Google Map and payment gateway are services. Totally agree. Yes, Google Map and payment gateway are services. Then what is component? The thing that you need to use in order to get the service. No lah. Okay, a component basically is a third party software that is created to be integrated into your system. Okay, I make it simple. It's a third party software that you buy or that you not subscribe. Most of the time you buy. That you buy and then you put into your system directly. Full integration internally. Let's say I want one component that do verification. Let's say my team doesn't know anything about hash algorithm. So let's say I hire Chris from another company. Chris, I need a software component that can do encryption using hashing algorithm 486. Alright. So he prepared the component. I buy the component from him. I take the component and then I put directly into my system, integrated internally. Be part of my system. That one is called component. But if I subscribe to a service and that service is hosted, if I subscribe to a function and that function is hosted somewhere else and I am connected through API, that one is called service. Google Map, payment gateway, all those are service. AWS, those are service. Right. Both of them are complete. Component are complete, service are complete. The main difference is that where do you host it? If you host it internally in your system, it becomes component. If it is hosted outside by somebody else, you subscribe to the service. That one is called service. And what is microservice? A much more specific function. Service can have a lot of things. For example, like payment gateway, you have payment, you have verification, you have response. So it has a lot of function, right? So that one is called service. But if the function is very specific, means that you subscribe only for one particular service, one particular function, not other things. Meaning that the thing that you subscribe doesn't offer anything else. Only one small thing. That one is called microservice. Stock market analysis service. Why? Because it needs to not stock. It needs to monitor the stock. And then he need to do some computation, and then he need to inform you of any changes or whatnot. So it offers a lot more services, right?
Then would the notification be the microservice?
No. This because it has a lot more that he can offer to other people. Maybe you are just interested with the notification. Okay. Right. So service-oriented architecture says this. I have an architecture where most of the component is about API. Means that I have my own internal system that need to talk to API that talk to another system outside me, hosted by somebody else. That one is called SOA, service-oriented architecture. Let's say let's say I want to do e-hailing system. Map, I use Google Map. Calculation of time, also Google Map. payment gateway. List of vendor. List of vendor I take from Shopee API. So basically my app has nothing. All I do, I just subscribe to everybody, to other API, and then I just configure them to create a new app. That one is considered as service-oriented architecture or microservices architecture. Right, but be careful. When you do that, when you do SRS, you already determine that you want to subscribe to external service. You cannot identify requirement. Then suddenly in design you decide I want to do microservice. It doesn't work like that. When you do requirement, you already identify some of the requirement will not be developed internally. We will subscribe from other people. It must be determined and identified clearly during SRS. Then only your design can go with microservice or service architecture. That's why for your assignment, none of you I give my approval for SOA or microservice. Because you didn't mention the intention inside your SRS. Okay, clear? Right, so microservice architecture basically is just an architecture where the structure of the architecture shows how your system communicate with another system through an API. So that is called service-oriented architecture. The diagram may look similar to 3-layer architecture, but you need to show how each layer connected to the API. What API do you use? What value that you send through the API? Value that you receive, value that you send. Okay, that is considered as SOA. Okay. For example, something like this, right? So now I have a service-oriented architecture. So I need to identify what are my services. Don't worry about the voices outside. We still have 10 minutes. What are the services, right? And how the services are connected to the interface, so on and so forth. Okay? So when you have SOA, basically you have a very high flexibility, reusability, and maintainability. Right? Reusability, maintainability, and flexibility. Very flexible because I can change the service. Let's say this service, Google Maps service is no longer accurate. Maybe Waze come up with their own API for developers. So I might want to use their API. So I can just switch easily. So that's why my SOA become very flexible. Right? Very flexible. However, SOA is not suitable if your system is GUI intensive. For example, gaming. Right? Gaming, streaming, song streaming like Spotify and whatnot, where the GUI is very intensive, then you should not use SOA. Why? Because when you use SOA, there is a transaction time that you need to take into consideration. If the internet down, then basically the whole system will go down. You cannot provide the service, right? Then suddenly your GUI become blank. It doesn't appear. Why? Because the service goes down. Same goes to my FYP student from last semester. When we try to capture news, he used one API. 2 weeks before presentation, the API shut down. The news part become blank. Blank. Right? Luckily, there are other API where we can retrieve local news easily. So that is the bad thing about SOA. So if you are GUI intensive, meaning that the input can be clearly seen from the API, then avoid SOA. Right? Avoid SOA. Right. Last one, interactive system. Okay, this one is the easy one, MVC. Okay, now we go to category number 5, interactive system. Category number 5, interactive system. So what is the main concern for interactive system? What is the nature of the system? The nature is that it has a very high interaction. High interaction between the system and user. For example, gaming, multimedia, and anything related to this too. Right? So the GUI need to be refreshed at very fast rate, right? For example, you play game, right? You shoot. It takes 1 minute for the bullet to go. Right? When it hit the wall, you can see the chip. Why? Because your refresh rate is very low. It doesn't look smooth, right? So for any system that need to have a very high GUI rate, refresh rate, then you need to use distributed system. So under distributed system, we have three. We have MVC, Model View Controller. We have MVP, Model View Presenter, and then we have Model View Model. But we are only going to discuss this. Okay, a quick one. I just show you the structure. So MVC is actually evolution from 3-layer architecture. If you look carefully, the architecture looks exactly like a 3-layer. So now I have control. So this is control. And then I have view. And then I have model. Okay, so now what control do? Control receive input. Okay, so meaning that any request from the client will come to control. Right. And then if control requires data or I need to do any kind of business logic processing, then that process will be sent to model. So model has two jobs. One is called business processing. Then number two is data modeling. If you remember 3-tier architecture, business logic and data are separated, right? But here in MVC, we combine them. So business processing, business logic processing and data modeling to prepare the data to be displayed to the client is done by model component, right? Then the data model that is prepared, let's say I want a report. Okay, let's say a client say I want a report. Let's say a report of final year student. I know that you guys are tired. 5 minutes. Right? I come here. So okay, you need a report. I send to model. Model, please retrieve all reports. So I do filter. I remove unnecessary input and whatnot. Once the data is ready, then I will send it to view. But what view will do? He will okay. The purpose of view is only to format output based on input or based on user need. Okay, so I prepare you data for all final year student for graduation. But to display the output in a report format, I need to have a table, a header, and whatnot. That one will be done by view. Then view will pass the information to client. If you look like this, it looks exactly like 3-layer architecture. Just that now the data is in the middle, correct? So now what's the difference between MVC and 3-tier layer architecture? So this is where the fun thing happens. What happens that control has a second responsibility. Control can do minor business processing. So meaning that any processing that does not require major verification, that does not require major algorithm or whatnot. Maybe for example, I just need to update. Let's say I choose Selangor, and then the district under the state will change to all the district in Selangor. If I choose Perak, so all the district will show me the district of Perak. That kind of changes. That one can be done by control. I don't need to go to model. So for any item that is not big in nature, big in size, it can be done by control. So meaning that control also have access to the database, but not the critical data. So that's how we cut short the. Okay, for example like this lah, when you shoot somebody in game, that person die. Of course that person need to lay down, right? Die. So I don't need to ask model to do the processing. That will be done by the controller. So certain processing doesn't need to go to model. I can go to controller. So what happens that the controller will update the view and pass it to view, and then view can pass it to client. So that's how we cut off some time. Okay. And then let's say a client do some update on the GUI. Let's say after I shoot him, that person die, and then I go to him and then I want to pick up his pistol or something. Again, that is not considered as a major transaction. So what I do is that from view, I can go back to control to request for update. Right? That person now is lying down. I go to that person. I want to grab his pistol or his gun or laser or whatnot. That update process, meaning that suddenly the laser gun disappear. It is in your hand, right? That will be done by the control, not by the model. Okay, but if for example, that person die and then I want to steal his life or whatever lah. When I get his life, then suddenly my life also increased by 10. That requires major processing. So from view, I can go back to model. I can skip control. This is model view controller. Some activity only between view and controller. No need to go to database and business processing. Some major activity we go from control, go to model, go to view, or maybe from view straight ahead to model. Right? So the transaction become much more dynamic between the layer. When this happen, I can update my GUI really fast. So high interactive rate. So that's why MVC is mostly used for gaming and whatnot. Okay? Done. Any questions? Don't worry, we will have another discussion about this in tutorial. In the tutorial question, there is a question about what is MVC. You are going to listen to this again. So MVC